All right, hello everybody. Today we're doing Objective 3 in our geometry review. We're talking properties of triangles. Okay, important stuff because as we move forward in geometry, triangles are going to show up a lot. There's a lot of different shapes, a lot of different geometric situations that we can break down into triangles. Okay, so important that we know some properties and how to use them. Here we go. Now, most of what we do today is going to be based on the triangle angle sum theorem. It just says this. It says the sum of the measures of the angles of a triangle are 180 degrees. In other words, if I take any triangle and take its angles ABC and add them together, I get 180 degrees no matter what kind of triangle I'm looking at. Okay, that's going to lead to several other theorems we're going to work with today. That's going to lead to a bunch of different types of problems we can do solving for angles. Okay, so that's kind of our base theorem for today. Okay, angles of a triangle always add to 180. All right, so let's go ahead and put that triangle angle sum theorem to use. Problem 1 part A says, what are the values of x, y, and z in the diagram? Okay, we kind of have a mess of a picture going on here. There's a few different variables we want to solve for. We're given a few angles, and it looks like there's a couple different triangles we're dealing with. Now, there's a few different orders you could do this problem in. I'm going to start by solving for x right away. And I'm going to do that by looking at just this triangle on the left side here. Now, with the triangle angle sum theorem, we just said that all three angles of a triangle always have to add to 180. So to find x, what I can do is I can take 180, the total for this triangle on the left, and subtract 59 degrees, and subtract 43 degrees. And when I do that, I'll get this last missing angle, this x, which will be 78. Okay, so I have x is 78 degrees. Now, once I know my x, I can find my y pretty simply. Okay, notice since x and y come together to form a straight line, a straight angle, I know their sum is going to be 180. Okay, so this isn't actually something new to this objective, but something that's going to show up a lot for us as we go through geometry. To find y then, since I have supplementary angles, I can just take 180 and subtract the x we just found, the 78, which will give me a 102 degrees for that one. Okay, last variable we want, the z. What I can do for the z is, since I know y now, I know 2 out of the 3 angles of this triangle on the right. And just like we did to start off with, anytime I know 2 out of 3 angles of a triangle, I can subtract from 180. So for z, we'll say we have 180 minus the 49 we're given up top. Okay, minus the 102 we just found, which will give us a 29 for the z. Okay, now there's a few other ways we could work our way around that one, but they all rely on that triangle angle sum theorem. Okay, pretty good problem solving happening here. There is some thinking, there's some kind of problem solving skills going on with this one, just like with the next one. Okay, your note guide has a problem B. Take a minute, pause the video, work your way through that one using the triangle angle sum theorem as well. And then before you move on, throw a hand up in the air, get that answer checked. Make sure you're good with that before we move on to the next problem. Next thing we're going to talk about are isosceles triangles. Now remember, an isosceles triangle is a triangle with 2 sides congruent. Okay, notice here, since both the left and right side have a single dash through them, that's how we'll represent congruence of segments. And the isosceles triangle theorem says that if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so again, since the left and right sides of this triangle are congruent, the opposite angles, the bottom left and bottom right angles, will be congruent, and they're marked with a single arch to show the congruence there. Okay, so if I know I have congruent sides of a triangle, we know we also have the angles across from them congruent as well. That's my Isosceles Triangle theorem. All right, so let's go ahead and use that Isosceles Triangle theorem. Problem 2, part A says, what's the value of x? Looks like a pretty straightforward question. Now, the trick with this one is since the left and right sides are marked congruent, I know that the lower left and lower right angles will be congruent as well. So what I can do is, since D has a value of x, F will also. And the way I can think of this then is I can say that x plus my 30 is equal to 180 degrees. Okay, because I know that all three angles should add to 180 because it's a triangle. And then that leaves me with a pretty simple equation to solve for the x, okay, to get that missing angle. Okay, combining like terms, x plus x is 2x. Plus 30 is equal to 180. If I then subtract 30 from both sides of this equation, that'll give me 2x is equal to 150. And if I divide both sides by 2, that'll leave me with x is equal to 75 degrees. Okay, and we're able to do that since we have an isosceles triangle. I only need one angle to find the other two. Now, that's kind of an algebraic solution. Okay, maybe a different way to think about it is we could say that x is just equal to 180 minus 30. Okay, so 180 for a total minus the 30 we know. And now that's going to give us the sum of these two last angles. And if I divide that by 2, since again they're congruent, we'll get the same x equals 75 degrees. Okay, it doesn't matter if you think about this one algebraically or more algorithmically or somewhere in between. Okay, either way we get that 75 degrees. All right, problem B is a similar question. Okay, take a minute, pause the video, work through problem B, give that one a shot. Okay, check your answer before we move on then. All right, next theorem we're going to talk about is the equilateral triangle theorem. Remember, an equilateral triangle is a triangle with all three sides congruent. And we can come up with this theorem based on the Isosceles Triangle theorem. Okay, it says that if a triangle is equilateral, then the triangle is equiangular. In other words, all three of its angles are congruent, with each angle measuring 60 degrees. Okay, basically if I take 180 and divide it by 3 for the three congruent angles, I'll get the 60. So anytime I see an equilateral triangle, I know all three angles are going to be 60, okay, no matter what size that triangle is. In problem 3, let's go ahead and use that equilateral triangle property. Part A says find the value of m and n. And it looks like in this one we have two different triangles, equilateral triangle on the left, and then just a right triangle on the right. And we have two variables we want to find, so it looks like we're going to have to use our equilateral triangle theorem along with some other properties of triangles. Now, again, anytime you see an equilateral triangle, we know that all three angles are congruent, and all three angles are 60 degrees. Okay, so to find n, what I can recognize is that in the upper right, I have a set of complementary angles. Two angles that will add to 90, and I can tell that from this right angle box. So for angle n, what I have is just 90 for the complementary angles, okay, minus that 60, because we know we have an equilateral triangle, which will give me a 30 degrees for angle n. Okay, to find angle M then, what I'll do is I'm going to look at this right triangle, isolate that, and since I know 2 out of the 3 angles, I know the 90 and I know the 30 we just found for angle N. Okay, just like I did a few minutes ago, I can subtract from 180. We can say M is equal to 180 minus 90 minus 30 In other words, 60 degrees for angle M. Okay, that's one example of using our equilateral triangle theorem. Okay, I can combine it with the triangle angle sum theorem or the isosceles triangle theorem like you'll do in the next problem. Okay, so once again, we have some different problem solving happening as we go through these. All right, once again, there's a part B to this one. Take a minute, pause the video, work through that part B, and then check your answer before you move on. The next thing we're going to take a look at with as far as triangle properties are going to be inequalities that relate the sides and angles of triangles. And the first one relates the different measures of sides and angles to each other. Two properties which basically say the same thing. First one says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So for this one, if xz is greater than xy, so the length of segment xz is greater than the length of segment xy, okay, then the measure of angle y, the angle across from the bigger side, will be greater than the measure of angle z, the angle across from the smaller side. So in other words, our bigger angles are across from the bigger sides, smaller angles across from the smaller sides. Okay, our other property basically says the same thing, but just flips the order around. Okay, if two sides of a triangle are not congruent, then the longer side lies opposite the larger angle. Okay, so again, same idea. If I have two angles of a triangle, A and B, and the measure of angle A is greater than the measure of angle B, so A is bigger than B, okay, then BC, the side across from the bigger angle A, will have a greater length than AC, the side across from the smaller angle B. Okay, so this one's just saying that the bigger sides are across from the bigger angles, smaller sides across from the smaller angles. All right, let's go ahead and put those properties to work in problem 4 here. Part A says order the angles from largest to smallest in my triangle here. Okay, largest to smallest, that means we're going to start off with the biggest angle. Well, the biggest angle is being across from the biggest side. 62 is the largest of the three sides here, meaning that angle B across from it will be the biggest angle. Okay, then my next longest side, 55, is going to be across from the next largest angle, angle A. And finally, since 47 is the smallest side, I know the angle across from it, C, will be the smallest angle. Okay, so based on these side lengths, I can order the size of the angles as BAC going from largest to smallest. In part B, we're going to do the same thing basically. This time we're going to order the sides instead of the angles. So here it says order the sides from shortest to longest. So I'm given the angles, but notice I'm missing one of them. So first thing I'm going to want to do with this one is find that missing angle M. And just like we've done a few times here already, we'll take 180, the sum of the angles of a triangle, and subtract 64 and subtract 51, which will give us a 65 degrees. All right, now that I know all three of the angles, I can now order the side lengths. Again, we want to go from shortest to longest. So the shortest side is going to be across from the smallest angle, 51. So my shortest side will be LM, we could say. 64 is my medium angle, so it's going to be across from the medium length side, MN. All right, and since 65 is the biggest angle, the side across from it, LN, will be the largest side. The next thing we're going to take a look at is how the sides of a triangle have to relate to each other. Okay, using something called the triangle inequality theorem. It just states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so if I have my three sides of the triangle, xy, yz, and zx, and I add any two of those sides together, they always have to be bigger than that third side. Okay, reason for this is if I have a triangle, or if I go to try to make a triangle where one side is bigger than the other two combined, my other two sides won't actually be able to reach, they won't be able to close up and make a triangle. Okay, so I can't have one side that's longer than the other two combined. It's another way we could word that. All right, so using that theorem, we can determine whether or not, given three sides, we have a possible triangle. So problem 5, part A asks, can a triangle have sides with the given lengths? Explain. Okay, 3, 7, and 8. I'm going to say for this one, yes, it can, because 3 plus 7 is greater than 8. Okay, 10 is greater than 8. Also, 7 plus 8 is greater than 3. And then we could also say 8 plus 3 is greater than 7. All right, there's no one side that's bigger than the other two combined. So I know that if you gave me 3 pieces of a triangle with these lengths, I could put them together and make a triangle. Okay, B, we'll run through this one together also. Can a triangle have sides with the given lengths 5, 9, and 15? I'm going to say for this one, no. Okay, because 5 plus 9 is 14. That's not greater than 15. That's false. And again, if I went to try to construct this triangle with a side length of 15, just kind of eyeballing things with a 5 and a 9, we'd end up with two sides that aren't long enough to close that triangle up, actually. All right, using the same triangle inequality theorem, we can also determine possible lengths of a third side of a triangle, given the first two. And that's what we're doing in problem 6. Part A says two sides of a triangle are 5 and 8 feet long. What is the range of possible lengths for the third side? Okay, so let's say that X is my third side length. Okay, well, what do I know about that X then? I know that it can't be bigger than the other two sides combined. So I know that 5 plus 8 has to be greater than X. In other words, 13 is greater than X, or X is less than 13. So that's going to give me a maximum side length for this triangle. I also want to figure out a minimum, though. So what I'll do with that is I'll take my smaller of the two sides I have. I'll take the 5. And we'll add it to the X. We'll say 5 plus X has to be greater than 8. And that leaves me with a pretty simple inequality to solve. We want to figure out what X has to be greater than. To do that, I'll just subtract 5 from both sides. So we could say X is greater than 3. So 13 is greater than X, and X is greater than 3. Compound inequality, I can put those together. I can just put X between the 13 and the 3. And that gives me a range of possibilities. Anything between the two of those numbers will work for the third side of my triangle. Okay, part B is a similar question, two different sides. You want to solve for the range for that third side. Take a minute, pause this video, work through part B, and then hit play to check your answer. Or raise your hand to check your answer before you hit play again. All right, the last thing we're going to talk about today is something called the Hinge Theorem. And this is really going to be kind of the same idea as the previous properties we've looked at relating sides of a triangle to angles of a triangle. Okay, where the bigger sides are across from the bigger angles, smaller sides are across from the smaller angles. Differences with a Hinge theorem, we'll use it to relate the sides and angles of two different triangles, okay, that have some congruent parts in common. Okay, so the Hinge theorem says that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent. Okay, so if I have two triangles with two sets of sides congruent and the angles between them are not congruent, okay, with the measure of angle A greater than the measure of an angle X, okay, then the longer third side is opposite the larger included angle. So since BC is across from the bigger angle, it'll have a be longer than YZ across from the smaller angle. Okay, the converse of that theorem just says essentially the same thing. If two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, so again, two sets of sides with third sides not congruent, then the larger angle is opposite the longer third side. So again, since BC is my longer side, I know that angle A across from it will be greater than X, which is across from the smaller side. All right, once again, the bigger sides are across from bigger angles, smaller sides across from smaller angles. Okay, just looking at that same relationship with two different triangles. All right, so last question we'll look at is going to be using that Hinge theorem. Problem 7, part A says, what inequality relates SK and UY? In other words, the length SK and the length UY, I want to figure out what can I put between the two of these, greater than symbol or less than symbol. Now, since I have my two triangles, and they both have two angles in common, two sides in common, two sides congruent, and the angles between those sides are not congruent, I can apply my Hinge theorem. And since this angle A is 90 and angle O is 70, I know the side across from angle A, SK, will be greater than the side across from O. So the inequality I can put between the two of them is just a greater than sign. I know based on this information here that length SK will be greater than length UY. All right, that's an example of using my Hinge theorem. Video's over, but still do work through the last problem. Check your answer, and then you can move on to the Math Excel, start practicing with all these properties of triangles.